So let's consider an example to see how distributed power control works in practice. In this example, we're going to consider three transmitters that are all within the same cell and are talking to a single base station. And we assume that the receivers are all co-located. We can think of them logically as three separate receivers because they're all looking for a different code. And again, as before, we have our direct gains, which we show as these horizontal lines here. But then the indirect or the interfering gains, which go to the other receivers, the unintended recipients. And so channel gain is what we're going to be looking at here a lot. And that's really a measure for all practical purposes of how much the signal is multiplied when it goes from source to destination. So if it's a factor of 0.5, then we'd say that this signal would go in half between here and here, and different channels are going to have different gain factors and different interfering factors, as we will see. And so, as I said before, each of these transmitters has different gains and different interfering gains, and so the way that we look at that is in terms of a table. And so these are the gain values here in this table. And so what this really tells us is, for instance, if the transmitter of link, if we're looking at transmitter 1, that the direct gain to receiver 1 is 0.9. So that means that 90% of the signal actually arrives at recipient 1. And at the same time, we have 10% or 0.1 of that signal arriving at receiver 2, which is the interfering gain, and we have 20% or 0.2 arriving at link 3. Similarly, we can look at link 2, and his direct gain now is to logical receiver 2, so that direct gain is 0.8, and the interfering gains are 0.1 and 0.2 respectively. And for transmitter 3, he's talking to link 3, and he has a direct gain of 0.9, interfering gains of 0.2 and 0.1 respectively. And the other thing that we have to specify are the target, so the target SIR. So we said before, the target signal interference ratio. That's what we want to get to. And in this table right here, we see that for link 1, we're targeting 1.8, which means that the ratio of the desired signals to the interfering signals has to be 1.8. So the desired or the received gain has to be 1.8 times greater than the interfering gain. And for link 2, it's 2.0. So this link is looking for a little bit of a better SIR for whatever reason, maybe because the phone needs a better SIR to be able to work properly. And link 3 is looking for 2.2, which is even higher. And at the same time, each of these links, we also specify slightly different noise levels. Really small right here. These are the noise levels. This is 0.1 milliwatts, or a tenth of a milliwatt. We have 0.2 milliwatts for link 2 and 0.3 milliwatts for link 3.